welcome to True Projects. In this video, we are going to explain about a project titled Supervised Learning Methods for Modeling the Concrete Compressive Strength Prediction at High Temperature. In the field of material engineering, accurately predicting the comprehensive strength at high temperature hold the immense significance for ensuring the structural integrity and safety of critical applications. To achieve this objective, our project immersed itself in the world of supervised learning method, a powerful approach that exploits the labeled training data to build precise predictive model. Our focus centers on harnessing this method to model and forecast the concrete compressive strength under elevated temperature conditions. Through the utilization of advanced algorithms and comprehensive data set, our aim is to develop robust and dependable model capable of providing the accurate forecast in extreme thermal environment. This pioneering effort strives to contribute to the advancement of high temperature structural design, fostering the creation of durable and secure infrastructure and demanding the settings, thus safety standards and the structural reliability. Our project goal is to create a comprehensive and accurate predictive model tailored to a specific application exploiting the potential of support vector regression, random forest, and recurrent neural network. The integration of these diverse algorithms allows us to capitalize on their unique strength in effectively handling the complex prediction task. SVR's proficiency in dealing with non-linear relationship empowers the precise regression prediction, while random forest ensemble approach enhance the accuracy through the combining multiple decision output. Additionally, RNN capability to capture the sequential pattern makes it invaluable for analyzing the time series data and generating the accurate forecast. The seamless collaboration of these algorithms aim to establish a powerful and versatile predictive system, surpassing the conventional method and ensuring the optimal performance across the diverse domains, marking a significant step towards the predictive modeling application. These are the basic requirements that are needed to build this project. Software requirements: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing libraries. In this step, we import the essential Python libraries such as pandas, NumPy, sklearn to handle the data manipulation, visualization, and the machine learning tasks. And the second one is importing the dataset. Here, we gather the dataset containing of various parameters such as cement, water, gravel, sand, fly, ash, plasterizer, silica foam, and many more. This dataset serves as the foundation for training and evaluating the predictive model. And the third one is data visualization. Before building the predictive model, we perform the data visualization to gain the insight into the relationship between the different input features and the target variable. Concrete comprehensive strength data visualization aids in understanding the potential correlation patterns that impact the prediction task and the model the building. And here different models are built. The first one is SVR, that is support vector regression. In this project, we employ the SVR as a supervised learning algorithm to build the regression model specifically designed for predicting the concrete comprehensive strength at high temperature. SVR excels in handling the non-linearity, which is crucial for accurately modeling the complex relationship between the input features and the target variable. Additionally, at high temperature conditions can introduce the multi-dimensional and intricate data patterns. SVR's effectiveness in handling the high-dimensional data ensures the model ability to capture the relevant information from the dataset. And the second one is random forest. Random forest is technique that having the construct multiple decision tree and aggregate their prediction to arrive at a final outcome. This ensemble approach minimizes the risk of overfitting and variance in the model, ensuring the better generalization on the unseen data with the capability to capture the diverse data patterns and the relationship. Random forest proves the instrumental in improving the overall prediction accuracy by combining the output of the multiple decision trees, and the random forest model boosts the reliability and the stability of the concrete comprehensive strength prediction, making it well suited for the complexities introduced by the high temperature condition. And the third one is RNN. It stands for Recurrent Neural Network, and this model is used for the time series data inherent in the concrete comprehensive strength prediction. It's a specialized type of neural network where its unique architecture allows it to retain the memory of the past observation, making it highly suitable for capturing the temporal dependency and the sequential pattern present in the data. High temperature condition can result in dynamic change over the time, and RNN ability to learn and adapt to the evolving trend ensure accurate prediction in such scenarios. By leveraging the temporal context and the sequential information in the dataset, RNN contributes significantly to the model's capacity to forecast the concrete comprehensive strength under high temperature conditions, further enhancing the accuracy and reliability of our predictive system. And the next one is training the model. To create the predictive model, we split the dataset into the training and testing set. The models are trained using the training data, where they learn the relationship between the input feature and the target variable. And the next one is user gives the input. We develop a user-friendly interface using the Flask framework, enabling the user to provide the input data for predicting the concrete comprehensive strength at high temperature. And the next step is the given input is pre-processed for prediction. The user provided input is pre-processed to align with the format used during the training. Data cleaning and transformation ensure that the input is suitable for prediction. And the next one is trained model is used for prediction. The pre-processed user input is fed into the trained models for the prediction. Each model processes the input and generates an output representing the predictive concrete comprehensive strength. And the last one is final outcome is displayed. The final outcome is displayed to the user through the interface. This valuable information can aid the engineer and the researchers in making the informed decision for the high temperature structural design and the safety assessment. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of various files within it. The static folder containing of the folders like of CSS, JavaScript, images within it, and the template folder containing of the HTML documents within it like of home, index, notebook, result, sign-in and sign-up pages within it. And the app is an py file which contains the information that related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And the DTS is the dataset that is in the CSV format is used in this project. And the model is an file contains the algorithm information. It loaded into the project code during the time at the trained model and for the various tasks such as making the prediction on the new data or performing the specific operation. A notebook is an IPYNB file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we build an Flask framework as a front end. For this, we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F. Because of this, the location is changed because our code folder is present in fdisk. Then write in command cd space and paste this address. By this, it will change the directory to the code folder path. And then click on enter button. Here we need to write another command, that is python app.py. Python space app.py. By this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. After running the app.py file, the Flask framework will host the application locally as of like this address. We need to copy this call local link and paste it on any of the web browser, and I prefer to use the Chrome, and then I click on enter button. Here we redirected to the page contains of the title of the project and sign in and sign up buttons. Click on the sign up button. Here it redirected to the sign up page containing of some details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirected to the sign in page containing of username and password. We need to enter the username and password as of admin and password too. And then click on login button. Here it redirected to the page containing of some input details that are need to be filled. And here the cement in kgs, that is of 300, and the water in kgs of 250, and sand in kgs of 400, and the gravel in kgs of 2000, and the fly ash in the kgs of 50, and the super plastizer in the kgs of 45, and the silica fume in the kgs of 45, and the nano silica in the kgs of 75, and the temperature is of 18. And then click on the submit button. Here the page is redirected to the result, and here it predicted as the comprehensive strength is of 46.397. By using this try again button, it will redirect back to this index page. Here we re-enter the details of some other, like of cement is 300, and the water is 500, and the sand is of 600, and the gravel is of 2500, and the fly ash is of 250, and the super plasticizer is of 155, and the silica fume was of 167, and nano silica is of 95, and temperature is of 21. And then click on the submit button. Here it is redirected to this result page, and it gives the comprehensive strength of 678.67. In this way we predict the concrete comprehensive strength at high temperatures. And in conclusion, our project has demonstrated the powerful potential of combining the support vector regression, random forest, and recurrent neural network and predictive modeling. The integration of these diverse algorithms has resulted in a comprehensive and accurate system capable of handling the various complex prediction tasks with efficiency. By leveraging their respective strengths, we have developed a versatile and robust predictive model. Significance of machine learning in driving innovation and improving decision-making process in numerous industries. Our research paves the way for future advancement in the field, emphasizing the importance of harnessing the collective power of diverse algorithms for more impactful and precise predictive modeling.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.